Imagine if we had a second home in space, a place where people could live, work, and build a completely new society. Mars is considered our most promising candidate. In this video, we explore the question of whether and how the red planet could actually become a habitat for humans. We look at the opportunities, risks, and concrete plans that are already underway. Welcome to erklärwürdig, worth explaining. Mars differs from Earth in many aspects, but also has striking similarities. For example, a day on Mars lasts almost as long as on Earth. A day on Mars lasts 24 hours and 37 minutes. However, a year on Mars lasts 687 Earth days. Just like on Earth, there are 4 seasons. However, these are considerably longer and also significantly more extreme. The average temperature on Mars is approximately minus 65 degrees Celsius. Depending on where you are on Mars, the temperature can fluctuate between plus 20 and minus 128 degrees Celsius throughout the day. The gravity on Mars is only about 38% of Earth's. This is useful if you're a bit overweight, because if you weigh 90 kilograms on Earth, for example, you would only weigh about 34 kilograms on Mars. Unfortunately, there's far too little oxygen on Mars. The atmosphere consists of approximately 96% carbon dioxide. The oxygen content is only about 0.3%. Without a spacesuit, this means instant death. For comparison, let's refresh our school knowledge. Earth's atmosphere consists of approximately 21% oxygen, 78% nitrogen, 0.9% argon, and the rest noble gases. The carbon dioxide content is 0.038%. The air pressure on Mars is around 6 hectopascals. For comparison, on Mount Everest, it's just over 300. As we've just discovered, this doesn't affect our breathing on Mars, since we couldn't survive without a spacesuit or capsule anyway. Interestingly, however, as the air pressure decreases, the boiling point of water decreases. The boiling point of water, the temperature at which liquid water evaporates, is 100 degrees Celsius in Earth's normal atmosphere at sea level. On Mount Everest, it's only around 71 degrees Celsius, and on Mars, it's around freezing at 0 degrees Celsius. We'll come back to this in a moment. Scientific research suggests that Mars may have once looked very different. Traces of rivers, lakes, and possibly even oceans suggest that the planet once had liquid water and thus potentially more life-friendly conditions. Billions of years ago, Mars could no longer maintain its magnetic field. However, a magnetic field is important to protect the atmosphere from solar wind and solar radiation. Due to the lack of a magnetic field, solar storms gradually dissolve Mars's atmosphere. Until now, the theory was that this is one of the reasons why there is no longer any liquid water on the surface of Mars. Due to the thin atmosphere, liquid water evaporates instantly. So, when the water ice still present on the surface of Mars is heated above 0 degrees Celsius, it immediately transforms into a gas. The water vapor is split into its elements by the sun's UV radiation in the upper Martian atmosphere, and hydrogen escapes into space forever. Theories are always valid until they are disproved. There are now speculations that salt water also briefly appears and flows on the surface. Large quantities of liquid water are suspected in porous rock layers beneath the surface of Mars. However, this water is found at depths of around 11 to 12 kilometers. Even on Earth, such deep drilling is complicated and expensive. Furthermore, the water is undrinkable and toxic. The question of why we want to colonize Mars can be answered from several perspectives. On the one hand, there is the scientific curiosity that drives us to explore the unknown. On the other hand, there are practical considerations. Earth is not invulnerable. Natural disasters, climate change, pandemics, or global conflicts could threaten our existence. A second home in space could serve as a kind of life insurance for humanity. The environmental conditions on Mars are extreme and pose enormous challenges. Average temperatures are icy cold, the atmosphere consists almost entirely of carbon dioxide, and the low air pressure makes survival impossible without a pressure suit. Furthermore, there is no protective magnetic field, which leads to significantly higher radiation exposure. Massive dust storms that can engulf the entire planet are also a reality on Mars. If humans want to live on Mars, they need protected habitats. These could be located beneath the surface or beneath large, dome-shaped structures protected from radiation and temperature with robust materials. Such colonies would be modular and would have to operate completely self-sufficiently. Everything, from oxygen to food to energy, would have to be produced on-site or efficiently recycled. A permanent supply from Earth to Mars would be extremely complex and expensive. Therefore, it is crucial to extract as many resources as possible directly from Mars. Water can be extracted from the ice in the polar regions or from beneath the surface. Oxygen can be produced from the carbon dioxide in the atmosphere through chemical processes. The Martian soil could also serve as a basis for plant cultivation, with appropriate treatment. Since regular replenishment from the Earth is virtually impossible, food must be secured locally. This could be achieved through closed systems in which plants are grown hydroponically or aeroponics. Various crops could thrive under special LED lighting systems, simultaneously providing oxygen and improving the indoor climate. Alternative protein sources such as algae or insects could also play a role in the future. Cosmic radiation on Mars poses a serious threat. Without a protective magnetic field, humans are exposed to significantly increased radiation levels, increasing the risk of cancer and other diseases. To protect themselves, Martians would have to either live in underground habitats or shield buildings with special materials. In addition, living in low gravity poses a challenge to the human body. Muscles and bones could deteriorate, requiring regular exercise and medical monitoring or creating artificial gravity. The distance from Earth has not only technical, but also psychological implications. Every communication is subject to a delay. Depending on the relative position between Mars and Earth, the average delay is approximately 20 minutes. This means no live conversations, no quick replies. Added to this is social isolation. Contact with Earth is limited, and life in such close quarters can be stressful. A stable psychological framework and regular simulations on Earth are therefore essential. Artificial intelligence and robotics will play a central role on Mars. Even before humans arrive, autonomous robots will analyze the terrain, extract materials, and build infrastructure. They will also be indispensable in daily life, for system maintenance, medical tasks, and navigation through the difficult terrain. The technology must be particularly reliable and fault-tolerant, as assistance from Earth will only be possible with significant delays. Today, not only government space agencies but also private companies are working on the vision of Mars colonization. NASA is pursuing long-term plans to return humans first to the Moon and then to Mars. The European Space Agency, ESA, Russia, and China are also actively involved in Mars missions. However, the US company SpaceX is particularly ambitious, pursuing the goal of bringing large groups of people to Mars with its Starship rocket. In addition to technical questions, there is also the question of social organization on Mars. Who makes decisions? How does coexistence function in a highly dependent world? How are conflicts resolved? A Martian society could test new models of coexistence, but it also carries the risk of inequality, isolation, and abuse of power. Precisely because the conditions are so extreme, it will be particularly important to create fair and sustainable structures. The idea of transforming Mars into a second Earth has fascinated scientists for decades. Theoretically, it would be possible to thicken the atmosphere and raise its temperature through the targeted emission of greenhouse gases. The use of algae or bacteria that produce oxygen is also being discussed. However, these processes would take many centuries and require technologies we don't yet possess. Terraforming, therefore, remains a concept of the distant future for the time being. Mars is a hostile place, but not unattainable. The technical, biological, and societal challenges are enormous, but they are not insurmountable. Researchers and engineers around the world are already working on the foundations for a possible settlement. No one can say for sure whether or when we will live on Mars. But one thing is certain, the journey there has already begun. If you enjoyed this video, please support my channel with a like, a subscription, and a comment. I look forward to next time.